Hello everyone and welcome to the lecture on Amazon Quantum Ledger Database, Amazon QLDB. So this lecture will contain all these topics. What is Amazon QLDB? Amazon QLDB key features, RDBMS versus QLDB comparison, QLDB data object model, working with QLDB data, historical data access, system catalog management, data streaming and integration, best practices and considerations. So what is Amazon QLDB? Amazon QLDB is a fully managed ledger database that offers a transparent, immutable, and cryptographically verifiable transaction log, all under the control of a central trusted authority, which is AWS in this case. You can utilize Amazon QLDB to track all changes made to application data, thus maintaining a complete and verifiable historical record of these changes over time. Ledgers are commonly used to record financial and economic activities within an organization. Many organizations implement ledger-like functionalities in their applications to maintain accurate data history. For example, tracking credits and debits in banking transactions, verifying the data lineage in insurance claims, or tracing items in supply chain networks. Amazon QLDB simplifies the process of creating ledger-like applications and thus eliminates the need to create custom audit tables or audit trails, often found in relational databases. It is a new type of database designed to ease the burden of building custom ledger solutions. QLDB employs an immutable transactional log known as a journal. This journal is append-only and is structured with sequenced and hash-chained set of blocks, each containing your committed data. The append-only nature and cryptographic hashing ensure data integrity and prevent unintended alterations. So, database concepts comparison. So, on the left we have database, and in QLDB it's called a ledger. Table is same, index is same. In a relational database we call it a table row, which is a table record. But in QLDB it's called an Amazon Ion document, and we have a column, but we call a document attribute. Then we use SQL, but in this case we use PartiQL, and audit logs. So audit logs, basically you can verify like who has made change, what was changed, all those things. But in QLDB this is the main feature, which is called a journal, and I'll be explaining more about journal and all those database concepts. So key features. So first is a journal first. So in QLDB, the journal, which is the core of the database, and it is an immutable append-only data structure where all write transactions, including updates and deletes, are committed first, similar to a traditional transactional log, but it is designed for direct user access and immutability. Journal, as I talked about, it's an immutable transactional log, so just remember this, and it tracks every change to your committed data and maintains a complete and verifiable history of your changes over time. So from this I will make it clear. For example, you have a vehicle registration, and this is the current state. So you have a vehicle identification number and the model and the year and the owner. So this one is the third row. So first somebody purchased a vehicle, then that person sold and it was bought by some other person, and thirdly it was finally bought and sold by this third person, right? And this is the current state, and now this whole history or the journal is maintained, and how it is maintained is like this. So first time when it was bought, it was our data was, or a record was inserted, and basically it contains all the data and what was the statement. And when it was inserted first time, or along with all the data, so initial hash was 0, so there was nothing. Then it calculated or computed a block hash of this whole data, and this was kept, for example, let's say with the data and also at another place, so that it can be verified. So let's say somebody finds out this data and calculates whether the hash has changed or not, right? So they can verify, and then they can verify with the central authority whether this data is same or not. So this is the first time purchase. So this is in corresponding to this entry, right? Next, when it was bought and sold again, so there was a transfer transaction type. So we have update vehicles, same vehicle identification number, but owner has changed. And along with the owner, it has computed. So we have the previous hash, which is this value. This is the previous hash, and it will take this value along with all the data that has changed, this whole statement, and then it will calculate a new hash, which is the block hash. And lastly, when the third time it was bought and purchased, then it got one more entry over here, and it did previous this hash it has maintained here, and it has calculated this along with this data, these two together, and it calculates a new block hash. So with this, if anybody changes over here, this hash will not match, and if anything gets changed over here, this block hash or previous hash, it will not match. And finally over here, so if any changes are there, if you just compare with the current block hash, you will realize that either the data has changed in the current or in the previous. So this chain will be broken, and this is how we will this is the main concept, which is the audit or the journal. So this is similar to blockchain, but blockchain is decentralized and this is centralized. So we are trusting AWS on providing this functionality, and this is specifically useful in, for example, high-end financial transaction, banking, insurance claims and all, where we want to make sure that the history of the data is is not tampered by anybody or any third party. So next important feature, which now if you have understood the previous, it will be easier to understand next 2-3 feature, which is, for example, immutable data. So QLDB, as you have seen, is append only, which means it keeps a complete unchangeable record of all changes to your data. There are no ways to alter or overwrite committed data, which allows you to access and query the full history of your ledger data. So it's only append only and it's immutable. And this diagram shows that the transactions are committed to the journal as blocks. So it will give a sequence number and it will just increment, and every time there is a change, it will have like insert, update, delete, whatever, and it will keep a hash also, as I talked about, and each block has a sequence number to specify its address. Next important feature is cryptographic verification. So as we have seen, QLDB uses cryptographic hashing to sequence and chain journal blocks, creating a hash chain similar to blockchains. This method allows for transactional data integrity and verification. Using digest and Merkle audit proofs, you can verify that no authorized changes have been made to your data. So there is something like Merkle tree or Merkle audit proofs, which is the underlying technology or the concept which QLDB is using. So in this diagram, the journal blocks are hashed using the SHA-256 cryptographic hash function and are sequentially chained to subsequent blocks. Each block contains entries that include your data documents, metadata, and the particular statements that ran in the transaction. So whatever statement also you run, it is kept in the journal blocks. So SQL-like querying. So QLDB uses PartiQL, which is an open source SQL compatible query language, along with Amazon Ion as its document oriented data model. PartiQL enables you to insert, query, and manage data with familiar SQL operators. Amazon Ion provides the flexibility to store structured, semi-structured, and nested data, being a superset of JSON. It's a superset of JSON. So it means it has all the functionality of JSON plus some more. Open source tools. So QLDB provides open source drivers in multiple programming languages. These tools simplify development by allowing developers to interact with the transactional data API and process results of particular statements. Serverless and highly available. So QLDB is fully managed, serverless, and highly available. It automatically scales to meet application demands without requiring manual provisioning of instances or capacity. Multiple copies of data are replicated within an availability zone and across availability zones for high availability. Enterprise grade. QLDB transactions are fully compliant with ACID properties, which are atomicity, consistency, isolation, and durability. It utilizes optimistic concurrency control and transactions operate with full serializability, ensuring the highest level of isolation and preventing concurrency issues like phantom reads and writes queue. So high level similarities and difference of RDBMS and QLDB. So these are the statements. For example, create table statement defining all column names and data types. And in QLDB, the create table statements that does not define any table attributes or data types to allow schema-less and open content. So here we have to specify schema, but here it's 100% schema-less. So when we say create table, we don't specify any attribute like columns and all. Create index in the RDBMS and create index for any top level fields on a table. So you can define even though you create table without any columns. Insert statement specifying values within a new row or tuple that adheres to schema. Insert statement. So when we do insert, we have to give the schema and the values. If you would have seen SQL statement, but in this case, insert statement specifying values within a new document in any valid Amazon Ion format, regardless of existing documents. So you can have, it's a schema, one record which will be 100% different than other record. There will be no schema. So one record can have its own schema. Second record or row can have, which is called as Ion document, can have completely altogether different schema. So select from where statement in the same syntax as SQL. So this is same when querying flat documents. So this is select from table where, this is like this, you have to read, and update table set where statement. So here in this case, update set where statement in the same syntax as SQL when updating flat documents. Flat documents means it's not nested document. So delete from where statement in RDBMS and delete from where statement in the same syntax as SQL when you are using flat documents, which is the Amazon Ion document. And in case of RDBMS, we have flat rows or tuples only. Documents that can have any structured, semi-structured or nested data as supported by Amazon Ion document format and the particular query language. So there is no built-in metadata. Select statement that queries from the built-in committed view of a table. So in this case, table have something called as built-in metadata, which is the committed view of a table. What was committed to a table, you can find out from there. That metadata about that, what information is in that row or in that table. So there is no built-in data history in case of RDBMS, but in this case we have. So we have this functionality, select statement that queries from the built-in history function. So this is important because as I talked about, it can maintain a history and you can query as an end user, you can query the history to see, and then you can verify also whether the history has not been tampered with or any of the older data has not been tampered with. There is no built-in cryptography or immutability. So in the case of RDBMS, and here in this case it's there. So there are APIs that return a digest, which is the SHA-256 hash of a journal, and a proof that verifies the integrity of any document revision relative to that digest. So next is QLDB data object model. So ledger, which is the database. So ledger is the primary AWS resource type in Amazon QLDB. It is created first and you can manage access to it using AWS identity and access management policies, which grant permissions to run API operations. The ledger ARN Amazon resource name format looks like this. We have ARN AWS QLDB service, the region, then the account ID, AWS account ID, then ledger fixed, and then the ledger name. Then next is journal and tables. And to start writing data, you create a table. Ledger data consists of revisions of documents committed to the ledger's journal, which is the immutable transaction log. Okay. And a table is a materialized view of those document revisions. In the standard permissions mode, you need IAM policies to run particular statements on the table resource. The table Amazon resource ARN format looks something like this. So we have ARN, AWS, QLDB, the region, account ID, ledger, and ledger. We have already come till here, then followed by table and the table ID. Then documents. So table contain revisions of QLDB documents. Documents are data sets in Amazon Ion struct format. QLDB stores the complete history of changes made to your documents, which are accessed using the history function or when querying the current state. And then we have system catalog. Each ledger, which is the database, each ledger has a system defined catalog. You can query to list all tables and indexes using information schema.user tables. In standard mode, you need QLDB particular select permission on this catalog resource. The catalog ARN format looks something like this. We have ARN, AWS, QLDB, region, account ID, ledger, ledger name, information schema, and the user tables. So from this, you can query, you can find out all the tables and the indexes which are there in this ledger, which is the database. Okay, this is how create table looks like. So there is no schema, which you just say create table. And then, for example, in the previous screen, we have create table to vehicle registration and vehicle based on the example which I gave earlier. Then you can create index. Then you can just use the table name. Even though we don't have a schema, you can have the index, because you will be using this field later on. So we have vehicle identification number and license plate number, and for the vehicle we have vehicle identification number. Then when you are doing insert, you will use the Amazon Ion document format. So you can just do insert into vehicle and put your entry, and you can add one more entry which has no which can have completely altogether different schema, so it doesn't matter. So basically this table is totally schema-less. And then you can insert into vehicle registration. So let's say there is a new vehicle which has just released in factory. So you will just give a identification number and the vehicle information, the model, make, and then when somebody buys, you can have some record inserted into vehicle registration based on vehicle identification number, who bought it, and the person ID, whatever. And when you want to do a select query, you will just say select star from vehicle registration, where, for example, license plate number is either this, or from vehicle, where the vehicle identification number is this or this. Then you can use join statement. This is the implicit join, this is the explicit. So you just say vehicle registration as R and vehicle as V, and R.win and V.win value should be in one of this. But here you are just more explicit that vehicle registration as R, but you are just saying inner join. So it only supports inner join. Then you can, as I talked about, you can select from history. So if you can do select from history, select star from history, then the table name from which date to which date as h and h.metadata.id and followed by the document ID. So you have to give this particular information, and this metadata ID will be based on the from the table information. You will get this metadata ID and which document you want to check out the history. So this ID is what for example, in our case, it's the ID of the vehicle registration, the vehicle which was bought and sold multiple times. You want to find out the history of that particular vehicle. So it will give some information like this, block address. So this is very long, but I have just put a snippet. So for example, this is just one. So what was the initial information? For example, this was primary owner first time bought, and that's some metadata ID. So this was replaced in the previous SQL query. So this is how it will look like. There'll be two more entry after this, and it will have its own block address. What was the hash, what was the data, and metadata, and all the information. So system catalog table. So you can just do select star from information schema, user tables, where name equal to vehicle registration, and you will get the system catalog table for that particular ledger. Basically, in this case, we are getting information for this particular table. But if we just do like this, it will give for all other tables also. So here it's telling what are the index on this table, the table ID. So you have to use table ID in certain scenarios, and what were the indexes and what is the current status. Okay, last topic is streaming data from QLDB. So Amazon QLDB provides the capability to stream its journal data in real time. So journal data, as I talked about, is the immutable transactional log. So it provides the capability to stream journal data in real time to Amazon Kinesis data streams. And this means that as changes happen in the QLDB ledger, a continuous order stream of record is made available. So streaming data provides several benefits. So you can have real-time analytics through other AWS services, the ability to keep other data stores synchronized with QLDB, an event-driven architecture for reactive systems, and a way to maintain a separate auditable copy of QLDB data. The journal within QLDB is the foundational source for streaming data. The data is then pushed to Kinesis data streams, which is a managed service that serves as a message bus for this information. The stream data comprises different types of records that capture various aspects of the changes. There are three major types of stream records. Control records indicate when streams are created or terminated. Block summary records contain metadata and information on the transactions that created the journal blocks. Revision details records give information about specific document revisions and the data changes. The stream of data from QLDB can be connected to a variety of other AWS services. Amazon OpenSearch service allow full text search on documents. You can have AWS Lambda, which enables serverless functions that can process the data and integrate with other AWS services. Then Amazon SNS and SQS allow notifications or queuing of message based on data changes. And Amazon S3 can be used to store stream data long term. Creating a stream requires that you have a Kinesis data stream to be the target for QLDB to send the journal data. Use the QLDB API or AWS CLI. You configure the stream with appropriate IAM permissions so that QLDB can send data and consumers can access stream data securely. To process the stream data, use the Kinesis client library KCL in applications that consume from the stream, or use AWS Lambda functions to process data and trigger events using other AWS services. When using QLDB streams, you need to be prepared for potential issues such as impaired streams and be ready to handle duplicate or out-of-order records using appropriate consumer-side logic. And that's all. Thanks for watching.